Okay guys, so this is the reaction that we were working on with the basic solution. So we had the cyanide ion plus the permanganate ion was going to come together and have a redox reaction to produce CNO minus plus MnO2. So in a basic solution, when we're balancing by using half reactions, we're still going to use the same ideas. So I still want to do oxidation numbers, which we did in the last video, and I still want to break them up into oxidation and reduction half reactions. Okay, so on this slide it shows, I already broke it down for you, showing you the oxidation numbers because again, we started that on the last video, but I think that's where it cut off. So in the oxidation, if I'm looking at carbon, I see that carbon goes from a positive 2 over here to a positive 4 on the product side, meaning that it's becoming more positive, meaning that it's losing electrons. So that's why I call this my oxidation half reaction. My reduction half reaction is going to have to deal with the permanganate ion, because over here manganese goes from a positive 7 and then it becomes less positive as a positive 4. So in this case, I'm gaining electrons, so manganese has to be my reduction half reaction. But to make sure that I write the half reaction correctly and balanced, I want to do each one individually by following the rules that we did earlier. So let's start off with the oxidation half reaction. So we have Cn minus going to CNO minus. We know this side, reactant side, has no oxygen, so we had a problem, remember? So if I have oxygen on one side, I'm going to balance the oxygen by adding water to the other side. So I added H2O here, so now I have one oxygen, one oxygen, one nitrogen, one nitrogen, one carbon, one carbon. So we're good that way, but, now I have these two extra hydrogens, and whenever we have hydrogen that we have extra that's from the water, we want to balance that hydrogen from adding water by adding hydrogen ion. So I added hydrogen ion over here to the product side. So now, if I just look at this reaction here, I am atomically balanced, but we're not electrically balanced, because if I look at this side, the reactant side, this would be a 0, this would be a -1, so the overall charge is a -1. But this side, the product side, would be a -1 plus positive 2 will give me a positive 1. And since this is oxidation, we know we have to lose electrons. So something plus that positive 1 is going to have to give me this -1 charge. So to do that, I'm going to have to add 2 electrons, which is why I also included the plus 2 electrons on the product side. So now we're atomically balanced, and now we're electrically balanced. Okay, so now let's look at the reduction half reaction. We're moving from permanganate to MnO2, and as we did from the last one, I'm balanced in terms of manganese, but I'm not balanced in terms of oxygen. So to balance oxygens, we add water. So I added 2 water molecules to the product side because now I have 2 oxygen plus another 2 is 4. But now I have 4 hydrogen on the product side and no hydrogen on the reactant side. So just like what we did in the last one, let's add 4 hydrogen plus ions, or let's just add hydrogen ion to the other side to balance. So I added 4 hydrogen ion over here. So now I'm balanced atomically because I have equal numbers of atoms on all sides, but I have positive 4 here with a -1. And over here I have a charge of 0 and a charge of 0. So I have a positive 3 charge right now over here with a charge of 0 on the product side. So that's why I included the plus 3 electrons. So then that way I would have a 0 charge on the reactant side to balance that 0 charge on the product side. So now we are balanced atomically as well as electrically. Okay, there's a big problem though, because what we've done is perfect so far. But this is a basic solution. This isn't an acidic solution. So what do? We add hydroxide on both sides of both half reactions. But why do I do that? I do that because I want to neutralize all of the hydrogen ion. And when we neutralize hydrogen ion with hydroxide, we make water from that. So ultimately, I'm getting rid of all of that H plus ion that's in solution and making it water, so then I'm just going to be left with hydroxide. So what does that look like? Let's see. So then that way it'll make a little more sense. Okay, so in the oxidation half reaction, before we had H2O plus Cn is going to yield CnO minus plus 2H plus 2 electrons. But I added 2 hydroxide ions to both sides of the equation because that's what the rule tells me to do. I'm adding the 2 hydroxide. And how do I know 2 hydroxide? You know 2 hydroxide because you want to match it to however many moles of hydrogen ion you have. Well, guess what? I have 2 moles of H+. So that means I want 2 moles of OH-. Why? Because when I have 2 moles of H+ and 2 moles of OH-, guess what I'm going to make? 2 moles of H2O. The 2 hydroxide on the reactant side isn't going to be able to cancel out or neutralize with anything, but this is a basic solution, and I want hydroxide present in this basic solution because then it shows that it's basic. So this is a good thing. I'm getting rid of my hydrogen ion on this side by using up all of the hydroxide to make water here, and then I'm left with the hydroxide over here on the reactant side. So if I rearrange what was on the last slide, this is what I'm going to get. 2 hydroxide ions plus H2O plus Cn- is going to yield CnO- plus 2 water molecules plus 2 electrons. And again, we're doing this because we're trying to show that this is a basic solution. Okay, so I did this to the oxidation, but I need to do the same thing to the reduction. So let's look at one. Okay, on this one, I went ahead and added the hydroxide as well. So I have 4 hydrogen ions that were present before, because in the previous one I had this and this and this, but the hydroxide wasn't there yet. Same thing here. I had MnO2 and I had H2O, but this hydroxide wasn't here yet. So I knew I had 4 hydrogen ions, so I needed to add 4 hydroxide ions to both sides. So these two are going to come together and neutralize the hydrogen ion to make 4 water molecules. So then the 4 hydroxide over here is going to be left. It's not going to balance with anything. It's not going to neutralize with anything else because, again, this is a basic solution, so we want it there. And if I rearrange all of this, I'm going to get this. I'm going to have my 3 electrons plus 4 water molecules plus MnO4- is going to produce MnO2 plus H2O plus 4 hydroxide ions. Okay, so we're almost done. I have both of my half reactions and they're balanced electrically and they're balanced atomically. But I have a problem. They don't have the same number of electrons on for both of them. So, because I want them to have the same number of electrons, let's say if we multiply this one here by, because I have 2 electrons here, but I have 3 electrons on the other one. So if I multiply the top reaction, the oxidation reaction, by 3, and if I multiply the entire reduction reaction by 2, that will give me 6 electrons for both of the reactions, or both of the half reactions, and that's what I want. So if I rearrange those and I multiply everything, let's see what that will look like. I'm going to get this. I'm going to get 6 hydroxide plus 3 cyanide is going to make 3 CnO- plus H2O plus 6 electrons. And that's for my oxidation reaction. For my reduction reaction, I see 6 electrons plus 4 H2O plus 2 MnO2 is going to make 2 MnO4- is going to make 2 MnO2 plus 8 hydroxide ions. Okay, so now I have equal numbers of electrons for both. All I want to do now is try to add them together, so then that way I can cross out what's in common between them, and then I can get my overall balanced reaction. So, first of all, I know I have 6 electrons on both sides. Let's get rid of them. We don't need them. I also see that I have 6 hydroxide here, and then 8 hydroxide on the product side, so I can get rid of all of these over here. And then I could get rid of this 8 right here, And instead of having the 8, I'm just going to be left with 2. And then the other thing that I have in common would be I have 4 water on this side, but I have 3 water on the other side. So I can get rid of that, all of that 3 water molecules over here, and instead of 4, I'm just going to be left with 1 water molecule. So if I write what I have left over, I have 3 CN minus plus 2 MnO4 minus is going to yield, oh, sorry, and a water. Forgot that water there, guys. Plus water. Okay, now we'll write our arrow. 3 CnO minus plus 2 hydroxide plus 2 MnO2. Okay, and I think I have it on the next slide. Oh, I do. Okay, so here is our final balanced oxidation reduction reaction. So let's check though, making sure that we have everything that we need balanced atomically and balanced electrically. So in this case, on this side I have 3 carbon, 3 carbons, so carbons, check. 3 nitrogen, 3 nitrogen, nitrogens, check. 2 manganese, 2 manganese, so manganese is good. I have hydrogen and oxygen left. So for the hydrogens I have 2 on this side, and for hydrogens I have 2 on this side, so hydrogens are good. For oxygens I have 2 times the 4 here plus 1 is 9, so I should have 9 on the product side. Let's cross our fingers. I have 3 here. Plus 4, so 7, plus another 2 is 9. We are atomically balanced, but now let's make sure that we're electrically balanced. Okay, so I have a -3 here with 0 and a -2. So on the reactant side, we have an overall charge of -5. On the product side, I have a -3 here, that one's 0, and that one's a -2. So on that side, we also have a -5. So we are balanced electrically. Yay! Okay, on that slide, guys, on slide number 30, there are 2 practice ones with the basic solutions. So you already have to do the 2 practice with acidic solutions. You should also try to do the ones with the basic solutions too, just because it's good practice. Okay, so hopefully this helps, and I will see you guys on Monday, and I think that you still have the one little small video since Promethean boards and iPads and overall just technology are being really poopy today. Okay, see you Monday. Have a great weekend and enjoy the beautiful weather. Bye.